Hey 30-2s, here's a lesson for exponential regressions. Now, we've done regressions in polynomials, so you should be good at this. It's an important skill for 30-2. So all we're going to do this time is we're going to do a regression on an exponential. And remember that we write our exponentials in this form here. Okay, and we're going to let the calculator do all the work for us. That's the cool part about this. So make sure you got your calculator. What I want you to do is we're going to go ahead and we're going to put the data in for bacteria A first, and then we'll do the data in for bacteria B. Okay, so grab your calculator and I'll walk you through how to do entering the data, just in case you don't remember. So on my TI, what I do is I go stat, then I go edit, and I put all my data in. So I've already got it in here for the first question. So just hit pause here and make sure you've got all your data in. Now that you've got all your data in, then what you do is you go stat over to calc. And now this is an exponential regression. So notice I'm hitting the down arrow a bunch of times and I get to 0 and I see exp reg, exponential regression. So we hit enter. Then we just go enter, enter, enter. And then right here, this is the really important part, friends, store regression. We go vars over to yvars, function y1. The reason why we're doing that is it stores it in our graph, and that way we don't have any rounded values. Now we've got a pretty easy equation here, so let's go write that one down. So our equation for this one was 4, 2 to the exponent x. Now this is really important. If you do not write it as y equals, you will not get full marks. I need you to write that like that. Okay, what I want you to do now that we've done one together is I want you to go and I want you to input the data for bacteria B. Just note, I had a little typo there that I noticed a little too late. So that last value is 486. Okay, so go ahead, hit pause and put that data in and get the equation, and we'll see if ours match. Okay, so there's your data. You should have that all in. And again, your steps, stat, calc, and then I'm just going to hit 0 for exponential regression. I'm going to go enter down to here. And now store regression, vars, yvars, function, y1. We got to put it in any list, any y we want. We might as well put it in y1. And there's our equation. 2 times 3 to the exponent x. Okay, so again, I know I said it just on the last example, but it's really, really important that you write that y equals, or else you won't get full marks. There it is. Okay, we now have the regression equations. Cool, calculator did it for us. Okay, let's answer some basic questions here. What do we notice about the A value? Well, the A value is this one, here and here. Let's go back up to our table. What do I notice? Well, I see a 4 and I see a 2. And when do I see them? I see them when time is 0. So what that tells me is the A value is my initial amount in the context of the question. Okay, it's also your y-intercept, but in the context of the question, it's the initial amount of bacteria. Perfect. Okay, at what rate is each bacteria growing? Well, I'm going to look at the 2 and the 3. Okay, well, that's my rate of growth. So for the first one, what I'm going to say is this one is growing at 100% every, what was it? Measured in hours, I'm guessing. Doesn't even say, we'll say, oh yes, it does, hours, okay? It's growing 100% an hour. Another way to say that is it's doubling every hour. For the second one, the B value is a 3. So I'm going to say it's tripling. That's by same as saying that I'm going up by 200%. Okay. Now state the B value. Well, the B value is 2 and the B value is 3. Okay. So what do you notice about the B value and the rate at which the populations were growing? Well, they're clearly related, right? They're clearly related. But here's what I want you to know is you're always going to think of starting at 100%. I always start with whatever I begin with is 100%, okay? And as a percent. But I'm going to turn that into a decimal. So 100% as just a number, I should maybe say is 1, right? Divide by 100, it's 1. So if I'm looking at this one here, the b value was 2. So what I'm going to say is, where do I end up? Well, now I'm at 2, and I started at a 1, so that's 1. What did I just increase by? I increased by 100%. That's me going up 100%. Okay, if I did it for the other one, I'm just going to do it right here. If I said, okay, now I have a rate of 3, but I started at 100%, that means 3 minus 1 is 2. Well, that's 200%. I'm going up by 200% each hour. Okay, so I always want you to think we begin with 100%. And the last question, what would a b value mean of 1? Well, if a b value was 1, so say we had this, well, this isn't changing. It's staying the same. I'm staying at where I started. If you want to think of it this way, 1 minus 1, I start with 100. There's no change. I got a 0% change. So this is why we don't explore these, because it's not an exponential. There it is, friends. So to do a regression again, the thing I really want to point out, you're probably good at these by now, is you must have this y equals right here for full marks. Okay, this is the only way to write it to get full marks. There it is. There is regressions.